Good morning, Kali. Today we are going to solve exercise 316 of the electrical circuit book, Fundamentals of the Electrical Circuit. This exercise asks me to determine the voltages B1, B2 and B3 by applying nodal analysis EHH. First of all, we know that here they work with conductance values of the conductance that is equal to 1 over the resistance. Therefore, the voltage that we normally calculate by N by R, if we calculate it in terms of conductance, we observe that the voltage would be equal to the current over the conductance. If we expect R from here, we have that it is equal to 1 over certain. Replacing this here, we have that the voltage is now calculated as the current over the conductance. What if we wanted to calculate the current by solving for the one here, where the current would be equal to the voltage over the resistance? In that order of ideas, EHH, the current would be equal to the voltage over the resistance, but the resistance is 1 over G. Therefore the current is calculated as the voltage times the conductance, right? That's what we have to remember. And well, starting from this, I'm going to delete this here. I'm going to start making another one. Well, another thing we have to clarify is if we have a voltage source, in this case a slope between two nodes. That's a super node. Okay. But being a super node, well, I'm going to remark this as a single node, and we have to take that into account when doing the current analysis. So now what I am going to do is a visual analysis of the current, and I am going to denote the direction of the current. For example, here in node B1 I see that the current enters and 2 enters here, and one has to grab fruit from one side. One of those paths that occurs to me is this, because here, at this point there is no voltage. The voltage is 0 and the current goes down this path. The other direction I assume is from this side that comes this way, passes through this resistance and comes this way. This current that comes from here reaches this point and has to take paths in one of those. Well, I assume it's that way, right? Later we calculate the current of this voltage and it reaches this point. You know that this node B2, the same node B1. When we do node analysis, the other current that occurs is going to be the one that comes from here. And I know this because they give me the polarity of this voltage, already having the direction of the currents. I'm going to give this one a name. I'm going to call it I1, huh? I'm going to call this one here 22, which is the same one. This one here, I'm going to call it 43, and I'm going to call this one current N4. So first I make the super node at this point, and I'm going to make all the currents that are going to be equal to all the currents that come out. I'm going to put the currents that come in first. One of those that comes into this whole point is the 2 amp one. I say that 2 amperes plus the other current that enters here, since it is seen that the current N444 arrives here. But let's remember that all of this is a single node. This would be I4. That will be equal to the currents that come out. The first current that I see coming out of this whole point is the current. And let's remember a node I1 and 1. The other current that comes out is current I2. I2, and the other current that comes out is current I3. It leaves this point plus the I3. So we already have the first analysis of currents. Now this would be 2 plus the current N4, but the 44th we know is this one that is here. This would be the voltage B3 minus the attention V2 minus the voltage V2, and instead of being about this time it would be because of the conductance 8. All this will be equal to the current I1, but the current I1 is the one that comes from here, which would be V1 times 1 plus the current I2 then the 1 that comes from here, which would be V1 minus B3 times 2, which would be the conductance. This one that is here plus the current and 1 and 2.43, which would be the one that comes here, would be V2. EP 2 times as times 4 as ready. Good. Huh? I start applying. Hey? It looks like I'm going to rewrite this equation here so that it looks better than me. I have 2 plus 8p3 minus 8p2 right. This is going to be equal to V1 plus this for this and this for this 2V1 minus 2V3. Two volts 3 plus 4 volts 2. Well, let's lower it here. Let's say applying. We move everything to one side, like everything that is constant and the variables and everything that is constant on one side and the variable on the other side. Hey, I'm going to move what's here and this to the other side of the same. 2. I have to V1. Further. Two volt minus 2V plus 4V2 minus 8V3 plus 8V2 equals 2. So V1 we have as 1 plus 2 would be 3 volts 1. 3 volts 1 plus whatever V2. Here I have 4 V2 and 8 would be 12 V2V. 12 V2 and whatever has V3 would be minus 2 versus 3 minus 8 V3 would be minus 10. V3 that's equal to 2. This would be our number equation. Hey? Okay. Now let's look here. To apply the supernode here I'm going to apply nodes at this point in the V3 node. If we look at the V3 node that is here with reference to ground, it has a value of 13 volts, right? Enter this point. This point would be the 13-volt node, so V3. It is equal to 13 volts. Well, we already have it, eh? We could say that we already have the two equations. Now the only thing I have left is, A, get a third equation and I can obtain that third equation in the following way, A. Whenever we make super nodes from there we must take what is the analysis for the last equation. Notice that here I have the super which is a dependent source and is between V1 and V2. I'm going to replace these resistors, these two that are here, with their equivalent voltage at the nodes. If I replaced it I would have the following. I'm going to do it here with Lido. So instead of putting the resistance that is at this point, from this point, I put the voltage between that point and that point, which would be V1. I can replace it as if it were a voltage source, which I will call V1. Next comes the dependent source. And that dependent source would be 2. Then comes what would be the other source, which would be P2, which is the one here, but that good V2 would be the same V sub 0, but well, let's put it as B2, right? Well, I have it like this. The polarities I give them by the direction of the current. The current comes downwards, it polarizes more, and from this side it polarizes more, less. That's why the polarities come like this. Now, if I do the LVQA at that point, I get that minus V1 plus 2 volts 0 plus V2 is equal to 0. But B0 tells me that this source is twice the voltage V sub 0, and V sub 0 is the one here. So V sub 0 is the same V2, which is 0. The voltage drop across this resistor, but the same V22 minus 1 plus 2 times sub 0, but V sub 0 is V2 plus V2. That gives me 0. Okay, so we overcome would be minus V1 plus 3V2 equals 0. Well, now what we can do is, like here we already have the value of V3. We can replace this value of V3 here. I'm going to go down, I have to replace it here at this point. 3V1 plus 2 volts 2 minus 10, which multiplies 3. The value of V3 is equal to 2, so 3V1 plus 1 2V2 10 times 3. Then it would be 130 to 130 equal to 2. Then I pass this to the other side with a positive sign adding 2. Then it would be 132. So 3V1 plus 1 2V2 equals 132. Passing this with a negative sign to the other side with a positive sign gives me 132, and I now have a new equation. I can equate this new equation with the other equation that I had here, this one here, because it would be minus V1 plus 3V2 equal to 0. This would stay with me. So we can solve this well with any tool that you like. I'm going to use MATLAB 312-1 and 3. 3 space 12 semicolon minus 1 space 3 3 1 2 3 1 2 1 3 minus 12 the other one is 132 and 0 132 point comma and then I started, and I have that the voltage V1 would be 18.8571. Voltage V1 would be 18,857 volts. Voltage V2 would be 6,280 and the voltage V3 would be 13 volts. Ready. We observe what the exercise asks of us. It only asks us for the voltages First Avenue 3 version 1, V2. Applying nodal analysis, what would this result be? Well, see you in the next exercise.